More factoring. Factoring polynomials completely. Most of this vocabulary is repeat. The new stuff has to do with the cubes. That's what we're going to be adding this time. Suggested previously, should know perfect cubes up to some appropriate number, at least 5 cubed, hopefully 6 cubed. And we're going to have some acronyms we're going to use to help us remember things here. So what's with more factoring? I said we're going to be factoring and using factored forms of things most of this year. So just a couple reminders. When it says we've been factoring completely, it's not to say we haven't been factoring completely. It's just now because our degrees are a lot higher, we're going to have more going on. So when I say factor completely, it's not anything different than what we've done. As far as our results, they're just going to be bigger. I want to just remind you, don't forget to always check first for what? GCF, greatest common factor. Now it's often going to be x with a higher power, so make sure that you pull that out first. And when we're talking about what's left, we always want to start with our special patterns so you don't do more work than you have to. So we're going to review what our previous special patterns were, and we're going to learn a couple new ones. So the previous special patterns we had were difference of squares, and that was like x squared minus y squared, where we would have our answer would be x plus y times x minus y. So looked for squares a lot. We're used to looking for squares both in terms of variables and in terms of numbers. There are perfect square trinomials. And as I'm mentioning these, remember what the graphs would look like when we just were graphing quadratics. What would the graphs of these look like? This would be x squared, in the back we'd have y squared, and then here we'd have 2 times x times y in the middle, right? When we had that, that factored into x plus y squared. And if it was with a minus, then it was x minus y squared. So those, we said it was best if you learned the patterns, but if you didn't learn the patterns, you could just go through a bunch of work. Well, the one that we're going to learn now, we're going to go on to cubes. So I want to start a new screen, but these, you just have to know them. There's not going to be a way to back into the work. You just have to know how to get them. So if I go through the cubes, what's 1 cubed? Well, that's 1. And let me just get the others up here real quick. 4 cubed, 5 cubed. You should definitely know up to 5 cubed, preferably 6 cubed. I'm going to put up to 10 cubed here just so you've seen them once recently, because some of these numbers have significance in your life, so maybe you'll remember them. But I just feel compelled to make sure that you've seen up to 10 cubed fairly recently. So I want you to think about, before I write these in, which ones do you know? Hopefully you'll write these in before I do. Pause if you'd like to try to write these in on your own. So 2 times 2 times 2 is 8. 3 times 3 times 3, 27. 4 times 4 times 4, 64. 5 times 5 times 5, 125. That's absolute must that you have to know. The next couple, I really, really hope you know. 343, I didn't remember till recently, so, you know, maybe not. And this one, I always remember that it has to do with computer stuff. So, again, you guys don't live in the day of 512K disks, so that's probably not quite as easy for you to remember. And 9 cubed, not so important, but definitely no 10 cubed. So, I mean, that one I would say is a must. 1 through 5 and 10, but try to get the ones in the middle too, because all you're going to do is save yourself a bunch of calculation if you know those. We're going to start with the sum of cubes. And if you get sum of cubes, difference of cubes isn't bad. I want to start with sum because when we had squares, we only had this for difference. So that's one big change, is that if I have a cube here and I have a cube here and they're attached by addition, I have a special pattern I can use with those. So if that's what I'm starting with, how can I factor it? Well, the first step I want to do is I want to worry about the numbers that I'm working with. Okay, first thing I'm going to do with my x cubed and my 8 is I'm going to take the square root of them. So, cube root of them. We haven't talked about cube roots, but square roots is 2, cube roots is 3. So the cube root of x cubed is x, and the cube root of 8 is 2. So it's saying, what do I have to multiply by itself 3 times to get what I started with? Well, I have to multiply x times x times x to get to x to the third, and I have to multiply 2 times 2 times 2 to get to 8. So x and 2 are the numbers we're going to be working with. We have a binomial and a trinomial. And this will be the same on sum and difference. Our answer to factoring this thing out is a binomial and a trinomial. So I tried to make my parentheses big enough to fit 2 things in the first and 3 things in the second. So the first thing I'm going to worry about is my signs. And where do I get my signs? I get my signs from SOAP. Why SOAP? It's just a little memory device. Same, opposite, always, positive. So that's telling me the signs that I need to write. Obviously well, not obviously, but the first term is going to be positive. We don't have to write a symbol. But the question is, what am I going to put here and here and here to separate the terms I'm going to write, the 2 terms for the binomial and the 3 terms for the trinomial? Well, SOAP tells me that because we started with a sum or a plus, this is going to be the same as that sign, right? Same as the original. Original was plus, this is going to be plus. Okay, the next blank that I'm filling in there is going to be the opposite sign to what I just wrote, and this one is always positive. So same, opposite, always positive. So that took care of the sign part of it. Now for the number part of it. I said we're going to be using x and we're going to be using 2. So we're going to write in x and 2. And that just comes straight down. So those are always just the 2 things that we came up with. And then this thing is going to be the first thing squared, the second thing squared, and then the 2 things multiplied. And I don't know if you know what SMS is. It's the kind of texts you're used to sending, right? The text message. So a lot of places in the world don't call those text messages. They just call them SMSs. And so here I did x times x, that gave me x squared. 2 times 2, that gave me 4. And this is just those 2 things multiplied together, the 2 and the x. So I use the x and the 2 3 times each. Right? They're used 3 times each. They're used once in the first parentheses. They're squared at the front or the back of the second parentheses, and then they're multiplied together in the middle. So if you need to write yourself some extra little notes in there, write yourself some extra little notes. So this is our answer. That's how you factor the difference of cubes. There's no, well, there will be a way that you could get it without knowing this, but the pattern is much easier to do. Okay, you definitely can do it with the pattern. So that's the pattern you have to know. So we used SOAP and we used SMS. SMS to get the numbers and SOAP to get the signs. So I'm going to do another one real quick. Let's do a difference this time. Next we're going to do difference of cubes. And it's the same set of rules. The only thing that's going to change the signs. We're still going to use SOAP though, so it's still going to help us figure out those signs. So difference of cubes is when I have a perfect cube here and a perfect cube here, and they're attached by subtraction. So I'm going to take the cube root of this, and I'm going to take the cube root of this. So the cube root of 125x cubed is 5x. The cube root of 216 is not 3, but 6. So we're going to use 5x and 6 3 times each. So we're going to have our binomial and our trinomial. I'm going to use SOAP first, and try to do this on your own if you haven't already. Now, same sign means the same sign as the original. So we had a difference this time, so that's going to be a minus. This is going to be the opposite of what we just wrote, and this one's always positive. And then we're going to use each of these guys 3 times. We're going to use the 5x here, and we're going to use it here, but we're going to square it. And we're going to also use it here. So we use that 5x 3 times. The 6 we're going to use 3 times also. Once there, once there, and squeeze that in there, once there. So this is going to be 30x. So that's the answer.